Okay, so as I just said in a little pre-word here, this is going to be tying some loose ends on things that we haven't finished, and tomorrow in-person class there is no new content, but I will be there to answer any questions, and right after that the test will be released, our first test this semester or this term. All right, so this was the last slide that we actually this was the there we go. This was the last slide. Okay, but I'm just gonna go back a little bit and back a little bit just as a review. Come on. Yeah, here's the tip and ring for the USOC. Where's the tip and ring? USOC, tip and ring, Universal Service Ordering Code for the USOC. RJ stands for registered jack. Tip and ring. The tip and ring comes from the quarter-inch jack. Why is it called quarter-inch jack? It is because the diameter of that is quarter-inch, and those little miniature jacks that you use for your headphones are 1/8 inch because it's 1/8, 1/8 of an inch diameter. Okay, tip ring and sleeve. That has something to do with the balanced or unbalanced signal, which we will cover today in a little bit greater detail than last time in person. Okay, excuse me. There we go. I just had to cough. All right, so the tip and ring is mostly used in the terminology. Tip and ring is used in the telephone lines, because in telephony we don't have balanced lines. However, since I'm showing you that jack, I might as well cover that because that has something to do with the sound system installations, which you will not be a stranger to when you go to work with the field. And the more you know, the more valuable you are, and the more money you make. Right? Right. Okay, so tip, ring, and sleeve, that's what it looks like, and things are being connected as such, and we'll come back to that before the cows come home today, all right? So because telephone line is just one pair, which is one wire and the other wire, and usually they're twisted, right? Remember? So we just use tip and ring. Some jacks have tip and ring and sleeve. Some jacks have just tip and ring. And in audio, some of those are being used for stereo versus mono signal, or balanced versus unbalanced signal. All right. Work with me. And this is also, we're going to cover in a little bit greater detail today, before the cows come home. Yeah, there we go. That's what tip and ring looks like. This is a telephone set, and this is the central office, CO, and this is a CO line, right? Or a single line. So CO stands for central office line, and SL line stands for a single line. Okay, interchangeable terminology. Okay. So main thing is that this is the central office. That's where the wires come out of. And this is the telephone set in your kitchen, on your kitchen wall, right? All right, so tip and ring is just one pair. Ring and tip, ring, tip. That's where it comes from. Okay? But we're not using those jacks, but the terminology stayed. And one important thing to grasp is that the tip is more positive than the ring is. However, the tip sits at the ground level, right? You just have to grasp that concept, right? And as I said before, the reason for that is when the telegraph lines were extended overhead along the railroads and roads and whatnot, originally it was the other polarity. Would be the ring would be negative and it would be tied to ground, and that's how it was. The lines were corroding, and reversing the polarity and sticking that positive to the ground level, and that stopped the corrosion. That's the reason. But that was a long time ago. All right, USOC configuration. we go with the pairs outwards. You see here, pair 1 is the old color code. You're going to still see that. Remember, in USOC, Universal Service Ordering Code, we count the pairs outwards. The two middle prongs is pair 1, and the pairs go outwards. So the green and red would be the pair 1, and the black and yellow would be pair 2, and there'll be white and blue. If there was another pair, there will be pair 3. So we just go outwards. Okay. Kaboom, kaboom. Let's keep going. Come on. All right, so here is the configuration of the old wiring versus new wiring, because the data lines, data cables, Cat5e can, yes, it can be used as a telephone line because it has a twisted pair. Actually, it has more than one twisted pair. It has 4 twisted pairs, blue, orange, green, and brown. Right? So the Cat5e cable, for example, or Cat6, if you really want to spare the money, excuse me, for no reason, or if that's the only thing you have, yes, Cat6 also can be used as a telephone line to extend it from, from the demarcation point, which is point of entry, where the lines are coming in, to a desktop or something like that. Yes, it can be used, but the telephone line cannot be used as a data line wire because it just doesn't have the ability to carry the data signal. Right? It has to do with the arrangements of the pairs and the twist that the pairs possess, mostly. Okay. All right, so here's tip and ring, pair 1, right? And it would go on the blue wire. If this was a jack that would carry 4 lines. And here's so on, black and yellow, white and blue. All right. Just, you can take a look at that and figure it out. That's how the USOC configuration. I'm not talking about the T568A or B, because with T568, the pairs are arranged a little bit different, and you have to remember that dance that I showed you, right? With the blue, orange, green, and brown, right? Pair 1, 2, 3, and 4. There you go. So this is just another visual on how the old color code corresponds to the new color code. Same thing that the last slide here, but just a different way of presenting it. Not going to spend too much time on it. Yeah, if you have questions, if you have questions, please ask me, but it's the same. Those slides are the same. It's just the same concept. It's presented in two different ways. Here's something that's called surface mount telephone jack. You can still buy those in hardware stores and things like that. So you can see this one is capable of 2 pairs. So you can see now the green and orange. If there was just one line provided to the house, you just connect the green and red. That's it. Polarity does matter, however, it doesn't. Okay, what do I mean by that? Well, you always should connect things with the right polarity. So tip and ring, green and red. So you should check out which one is tip and which one is ring. And what do we have here? Tip and ring. Okay, so the green would be tip and the red would be ring. All right. However, if you by accident, sorry, I'm going the wrong way. If by accident you wire it backwards, the telephone is still going to work because the telephone sets have inside installed something that's called a bridge rectifier. And the bridge rectifier, it consists of 2 diodes connected in some sort of like a diamond-like configuration. It looks like a diamond or square. And that takes care of the wrong polarity in the input. Doesn't matter which way you connect. At the output, you're still going to have the correct polarity. So take a look at something that's called bridge rectifier. It's mostly used for rectifying AC signal into a pulsing DC. But it can also be used in because of its properties. Maybe I'll show you sometime. Right? All right, now here is a demarcation point, something that you can see on the side of the house sometimes. How does it work? All right, the lines are coming from the city here, and they're connected here. So you can see there's green here, and there's a red wire, and another green wire. So this demarcation point, as it is configured right now, is capable of receiving two lines or servicing two lines. So you can have two telephone lines coming out from outside, and it will provide two telephone lines. How does that work? Okay, so these two blocks, those green blocks, and here's that little bolt and nut. That's a ground, that's connected to ground. This is not just a regular plastic piece. It is, I'm not sure how it is made and from whatever the chemical consistency of that is. The important thing is that if there's a lightning hit, this material has enough resistance to be considered as an insulator under normal circumstances. But if a lightning hits, the voltages are humongous. It has enough resistance to, or has enough conductivity for the lightning to take the hit of a lightning. So the lightning is going to stop here, and the lightning energy is going to go to the ground through this little material here. And it's not supposed to go further into the house. Well, that's the plan. All right. Does it work? Of course. Mostly, I guess. All right. It's one of those philosophies that, something's better than nothing. Well, here's the thing. If you even extend a telephone wire or any kind of wire outside, it should go through lightning protection. So this part here is a lightning protection. Then those wires are connected to the jacks here, and into the jacks are plugged in plugs. So here's the line coming in. It is terminated at that black jack over there. And over here, there are a couple of screw terminals that carry the line further to your house. And here is the little telephone cord that plugs into the jack. So you can still disconnect that line by just unplugging it. So this is the simplest version. Do all demarcation points look like that? No, this is just one example of it. Right? Some of them are more sophisticated with buttons to push and whatnot. Right? But that's the general idea. All right, now, how does the demarcation point look like in some of the bigger facilities? Well, see here, what do we have here? Here is another demarcation point, but this one here, if you open the hinge, which, the providing companies will tell you that you should not, and that's actually, there's no reason for us if you're not working for the bigger company. But if you are, then by all means, it's going to be part of your job to operate that. So there's going to be a bunch of buttons with the lines, numbers, and you push that line and you activate that line. If you unpush that, you deactivate that line, providing that there's a signal going into that from outside. And what do we have here? Out of here, well, into here, there's a 100 pair cable, and but we don't see it. But into here, from out of this demarcation device, there's a 100 pair cable. What's a 100 pair cable? Well, it's 4 25 pair cables in one jacket. Remember, the colors are the pairs or the bundles. Bundle 1, 2, 3, and 4 are distinguished by a ribbon that is wrapped around every bundle. And when you strip the jacket thing here, you should keep those ribbons and tie those ribbons around each bundle. Now, see here, this is popularly called a woofer or a connector, 25 pair connector. So this connector is capable of connecting 25 pairs, and we have, oh look, 4 of them. That thing here accommodates 100 pairs. One of our labs will be connecting a 25 pair cable onto one of these. Right? It's a fun lab. Right? And that's what basically, now from here, this is the field wiring. So over here, there are cables that are going to the desktop or wherever they go. So if there is a telephone line that needs to be connected to one of the lines that's going somewhere from here on the other side, then you get something that's called a cross-connect wire. Connect that to this pair, run it across, and connect that to this connection or whatever it should be. Right? There's some other connections that are going wherever they go. But that's basically the idea of cross-connecting telephone lines. So here's a line coming from the outside, it's terminated somewhere here. That thing here is terminated to wherever it should go. And sometimes there's a whole 25 pair that goes into a secondary demarcation point somewhere there. It's servicing maybe large department store. Okay? What else do we see here? Just as a from curiosity here, you can see a couple of, you're going to see those less and less. But still, if you see something like that, that's something that's called a T1 connection. And we're going to talk about what T1 connection is later. Right? So in North America, it's something that's called T1. And in India and Europe, and not sure where else, it's called E1, as in echo, E. It utilizes couple of, like each of the modems, it utilizes couple of pairs to modulate the signal for multiple telephone lines. So on four conductors or 2 pairs, you can have something like, I'm not sure, 12 lines, the equivalent of 12 lines. So it's modulated on that side and it's demodulated and it's punched into here, so you can actually have those lines. So here's a couple of modems, and they're called T1s in North America. T1 and E1 is the same idea, but it has a slightly different, the specifications are slightly different, so that's why we distinguish those T1s from E1s. All right, POTS filtering, DSL loop, dry loop, and voice. Okay, during the when the internet technology or the internet providing technology was being developed, and it constantly is, at some point the DSL was introduced. DSL stands for Digital Subscribers Line. The Digital Subscribers Line is an internet signal superimposed onto a telephone line. So the telephone line would carry the voice, the regular telephone circuit for your telephone, and on top of that you would have the signal for the internet. Problem was that the signal, the internet signal, or the DSL signal, Digital Subscribers Line signal, would produce a slight buzz and would be quite annoying if you were talking on the phone. So there were a couple of solutions. One would be plug in that filter into the telephone jack, and then you plug in your telephone into here. So this filter would filter out that noise, and this jack right here would be just used just for voice, for telephone. Now, here's another solution. Right at the demarcation point, which is somewhere here, if there's a telephone line coming in to your house, right here, you could run that DSL line into that filter right here. Yeah. So that line would go right into the line. Now, this particular POTS, plain old telephone service filter, see, this is a DSL POTS filter. It works like this. There are some different ones, but the idea is the same. This particular one, the good thing about this, or the nice thing about that, is that you can just use the screw terminals to connect the telephone line, or you could plug it in with the telephone jack. Either or, it just works fine. So you have the option. Very installer friendly device. So you would connect the telephone line here, and it would have some wonderful magic circuitry inside that would discriminate the signal and send the DSL into this jack, and that would be connected to the modem for your internet at home. And this here would be connected to the telephone line that provides the signal to all the telephones in your house, which means that you would not have to use that at every phone location. Okay, so there's that, right? Now, here is a terminology. DSL stands for Digital Subscribers Line. Voice is a voice line. It's a telephone line. What's a dry loop? Okay, at some point, the cell phones became really popular, and it wasn't that long ago. Not everybody had cell phone. It was considered to be somewhat of a luxury. Now it's pretty much a necessity for you to have us, for us to have cell phones. But there was that turnover period, turnover time, that people would decide, say, look, you know what, I think, I have a cell phone, my wife has a cell phone, my kids have cell phones. Why do we need a landline? Why do we need to pay every month for something that we don't really need, but we still would like to have, because we have a pretty good deal on the internet through the telephone line. So is it possible to just cut off the telephone signal out of that telephone line and just keep the internet signal? And the providing companies said, well, why not? So they constructed something that's called a dry loop. And a dry loop is a telephone line signal on the telephone line that doesn't have a telephone circuitry connected to. So there is no dial tone. It's a telephone line with just the internet signal without the voice signal, with the voice circuitry connected to it. So you cannot plug in a telephone and use it because you will hear nothing there. But it just has that DSL, digital subscribers line. So that's a dry loop, not to be confused with something that's called a hard loop. Okay, here's the difference between a dry loop and a hard loop. Dry loop is a POTS line with only DSL signal, which I just explained. All right, and here's another visual on how to connect that thing. Here's a phone jack, or right at the demarcation point, you can connect that to that POTS filter into the line, and here's signal that goes to the modem. And if you have a phone, you're still paying for the phone line, you can connect that out of that, and you don't need those individual POTS filters for individual jacks. All right, now both of these are loops, but you're going to hear something called a dry loop, and you're going to hear something called hard loop. Hard loop has nothing to do with the phones, although in some cases, yes. And I'll tell you how. Now, why not? If it's connected to a T1, remember that modem here? There you go, that one there. All right. Sometimes you have to plug that into one of these for the diagnostic purposes. When there's a new T1 line inserted, sometimes you will be asked to get a hard loop, plug it into there, make a phone call to whatever the company is providing that, and they're going to ask you to plug in the hard loop, and they're going to do some testing, and they're going to ask you to unplug it and say, yep, it's good, or no, it's not good, we have to do some more servicing. Okay? So hard loop is a diagnostic tool that basically what it is. You see, remember what I was telling you during the labs? Let's say, for example, Cat5e only uses two pairs, orange and green. One is transmit, one is receive pair. And which one is which? It just depends on which side of the cable you're looking at. Right? Point is that one of the pairs sends signal, the other pair receives signal. That's it. Now, if you want to make something that's called a hard loop, you take the Ethernet jack, RJ45, and you connect, and you just loop it. You connect the transmit pair into the receive pair. You just loop it. And sometimes you're going to be asked to use that for diagnostic purposes. Basically, with that T1 section, there's the modem. That's one of the examples. It has that Ethernet jack there, or RJ45 jack. And you'll be asked to plug in, so that jack is, it has one receive pair, one transmitting pair. You're just looping it for someone from outside who's logging into that modem, who can perform some diagnostics on this thing when it's brand new installed, line, or if it needs servicing. Okay, so here's the difference between hard loop and a dry loop. Okay, now last thing about this thing here is wiring configuration. It used to be like this here on the bottom. There will be a telephone line provided to home, to your house, and that would be the one of those outside boxes that I showed you. And from there, the line would be connected to the first jack, and then parallel connected to another jack, and parallel connected to maybe another jack. So you would have just something that's called a daisy chain connection. In that case, some of the good old days, if your sister is talking on the phone with her boyfriend, you could go to the other room and pick up the phone, and you can hear he ha 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 what she's talking about with her boyfriend, right? And then she would get really mad at you and throw something at you. Okay, so that that was the idea. No, not really. Okay, but that's how telephone lines used to be connected. Now we're not only not using a telephone wire to connect telephones, because it's a good idea to use Cat5e at least to run the signal to your telephone outlets, but we're connecting that as a star configuration, so everything home runs, and you have a little bit of a patch panel into that and if you have a Cat5e, for example, Cat5e connection between one end and the other, and all outlets individually, not daisy chained, then you can use each and individual outlet as a data or phone. That's the idea. So any new installations in a residential setting, then you would not you would use something like that. Now, in commercial, the daisy chaining is just pretty much out anyways. It's gone. So everything home runs to the LAN room. Okay? And this is the 25 pair color code that we already studied. Now, I got a couple things to show you. Let me just cue them up. Here and here. All right, so what I did is I made a little simulation in the multisim on how the telephone line works, and I'm talking, well, things are much more complex, but I'm just going to show you how the voltages work. Okay. All right, remember there's a tip and ring. Here's tip, which is more positive than the ring. See here, tip and ring. More positive than the ring, but it's connected to ground. And here is the battery, DC battery. And here is the telephone set. So here's a terminology that you might hear. There's no dial tone. Okay, there's no dial tone. Should there be? Yes, they should be, they have purchased the telephone line here, but there's no dial tone. And you might hear a question, is battery present? Well, what they mean is there that 48 volts present across that. So the telephone line, as it idles, it has 48 volts across. That's it. That's in idling. There's 48 volts voltage DC across the pair. See, tip and ring, across the two middle prongs, 48 volts. Actually, it is negative 48 volts because the positive is connected to ground. It's grounded. Okay? It's at the potential of the ground. Now, when the phone rings, I just made a couple of switches. It's much more complex, but this is for the simplicity. So here, battery is present now, battery is not present. So this will be a completely disconnected line. So let's, here, I'm going to activate the oscilloscope here. Bring it in. All right. let's see what we have here. I'm just gonna bring it over here, okay? So I hope everybody can see things. All right, and let's just activate the circuit by pressing the little play button here. Boom, so we have an active circuit, and I have adjusted the line here. So we have, oh, there. We have that 0 here. That's our 0. Where's the positioning? Here, by the positioning here. I positioned that at 0. Okay. Let's get the cursors out. Where's the cursor? Hold on. Yeah, there's the button that says cursor. So I'm just going to make them disappear. Can I make them disappear? Oh. Yeah, I'm just going to take the cursors just so we can see things better. Just like the little Red Riding Hood with the wolf. She comes to her grandmother and she says, "Grandma, why do you have such big teeth?" And she says, "So I can see you better, okay?" Yeah. That's how it goes. All right, so now we can see things better. Here is our 0 line on the oscilloscope. And let's turn on the DC circuitry that goes into the phone line by pressing on that switch. You're going to notice that this line here is going to jump down to negative 48 volts. Here, watching it, look at that. Press. Oh, he hit that, you know? There it is. So this is negative 48 volts. That's the idle. When there is the AC signal of 90 volts peak to peak with the frequency of 20 hertz superimposed onto that, then the phone set is going to sense that, and it's going to produce a ringing tone. Why 20 hertz? Why 90 volts peak to peak? Well, it comes from the good old days, like 100 years ago, or maybe less, where there would be a couple of bells left and right, and there would be like a little hammer and a transformer attached to it, and that AC signal would be provided to that transformer, like a double transformer, and you would power either one or two the other transformer, and you would just bring that hammer or magnetically, and that hammer would hit one bell or the other with the frequency of 20 hertz. So here's that characteristic telephone ring, the classic telephone ring. That's what it sounds like if you have it on your cell phone. All right, now let's see what happens to that, because see, there's battery present, battery not present, battery present again. We're just talking about the voltages. Negative 48 volts across that. Negative 48 volts is in North America. I'm not sure what it is in Europe. I would assume it's something similar. All right. So now let's make the phone ring by pressing that signal here, pressing that switch. So we are superimposing that 90 volts peak to peak. Oh, look at that. Here is the negative 48 volts, and here is the 90 volts peak to peak superimposed on that. So telephone rings, telephone no rings. Right? Ring, no ring.
So, sir,
Ring.
that's what the AC volts are for? The
That's
ringing?
for ringing. Yes. Yeah. Okay. So if you're
You
holding
need
that,
90 volts, sir, to ring a
yeah,
phone?
90 volts minimum. Yeah, to make the phone ring. And that comes from the old days that you actually needed that voltage to make those transformers, active and start ringing those couple of bells that were mounted on the wall. Right? Now, here's the thing. Good thing you asked, okay? Because right now, there are devices that are called ATA adapters, and ATA stands for analog telephone adapter. And those analog telephone adapters, those ATAs, are being used to interface various phone systems with other peripheral devices. The peripheral devices could be as such. It could be something that's called a paging interface. A paging interface is a device that connects the telephone system, whatever that is, to a PA system. So you could make the announcements or general announcements using your any phone that's connected to the system, just by picking up the handset and punching the feature number or the button that says page, and the signal will be transferred from the telephone system onto the little mixing board, which is connected to maybe an amplifier, which is connected to paging speakers or horns. All right, now those paging interfaces, or the paging interfaces, they work on POTS, plain old telephone service signal. They understand the POTS. So in order to activate a paging interface, you need to produce a ringing signal for that thing to automatically respond and react whichever way you program it to react. So the paging interface is looking for that. So there are different brands of, like, we'll talk about that when we get to it. Like, for example, if there's a VoIP telephone system, the VoIP telephone system doesn't connect into any box that's sitting or hanging on the wall, although it can be, and we'll talk about too. But it's all Ethernet. It's all Ethernet signal. So you would install something that's called the ATA adapter, analog telephone adapter. Acts like a phone, connects to the network, makes the network think that it is a phone, but it's just a black box, rectangular box. And it receives the Ethernet signal, and it provides the ringing signal on its output. Then the ringing signal has to be 90 volts peak to peak, and it has to have certain capability or ampacity to provide current, which means sometimes if you have some weird problems, that everything is connected properly, everything is fine, there's no mistakes that you have made, everything is, and the paging interface is connected, the ATA adapter is connected, everything is online, everything works, but the paging interface doesn't respond. Is there something wrong with the No. Most of the time it would be something that maybe there's a new model of that ATA adapter, and it's somebody didn't pay attention to provide exactly 90 volts minimum, or the current capability for the paging interface to be powered. So sometimes you're going to have some weird problems like that. I'll tell you more when we go further with the theory classes. Now, here's another system. You know what? I could probably, if you were working with multisim, you know how to use multisim probably by now. I can probably put those files for you to grab and play with them. Okay. Now, I'm going to show you something else. Now, let me just make sure that the other one is deactivated. Yes, it's stopped. All right, here's another thing that I'm going to show you. We're almost done. Remember when I was talking to you about balanced and unbalanced signal? Right, here is how a balanced signal, because the idea is that over a longer distance, if you have a weak signal, over the longer the distance you have, the more the cable that's carrying that signal is susceptible to outside noise. Like if I want to great brand's car drives by, or maybe there is some equipment kicks in, or somebody turns on the vacuum cleaner or something like that, right? So in pro audio, that's unacceptable, because if you have a stage or live stage, or if you have a recording studio, you would hear all kinds of noises on the cable, so that's not good. So here's how things were solved by using something that's called a differential amplifier, and this thing here stands for an operational amplifier, op amp. And here is 741 is the most popular one, but this is more actually higher quality one for use for audio. And this is how it is connected. I got that schematic from here is this reference here, so I just
Yes.
yes.
Is like all op amps used for like telecommunication communication type aspects?
No, some of the op-amps are being used for various mathematical operations or logic operations. Okay, they have, some of them are being used as amplifiers or preamplifiers. This one is being used as a, differential amplifier, like a microphone preamp, to receive a balanced signal. Okay. How is the? Did I answer your question, or if
Yes,
you need
sir. I have a next question. Can like a capacitor do the same thing?
capacitor? Yeah. Well, here's the thing. Once you start playing with the RC circuits or RLC circuits, there's give and take. You can do a filter out the noise, but you would actually start going into filtering the signal that you want. So yes and no, right? Depends on the situation. Yeah, and plus the op amp here, it can receive very weak signals and amplify them onto something that is useful by us. And capacitor is a passive circuit. The RLC or RC circuits, they're passive circuits. So, well, in some cases, the RLC or RC circuits mostly are being used as filters. And you want to filter out the noise, but with the noise, you can actually filter out the true signal as well. So my answer is yes and no, okay? Depending on what you want to do with it, right? What you want to accomplish. So let me just show you this thing here before we wrap up for today. Here is what the Pro Audio microphone, that's a Shure SM58, and it has 3 pins. Pin number 1 is the signal ground, which can be actually connected to true ground, but it doesn't have to be. It's something that's called a virtual ground for the operational amplifier. If you study those, you'll know what virtual ground is. But that's the middle line, okay? Now, number 2 is a non-inverting signal. Number 3 is an inverting signal, negative. How does that translate into here? Here's a simulation of that. Here's the positive and negative. That's how you get, when you speak to the microphone, you get 2 waveforms, 180 degrees out of phase. They're the opposite. Here's the idea. Okay, so here's a signal and here's a signal when you speak to the microphone. I just put 2 different AC power supplies or signal generators here. They are same frequency, same voltage, 180 degrees apart, the opposite. Now here, right now, it's 0 volts because first I'm going to show you without the noise what the signal looks like. So they're ready to make noise, but these will be in phase because the noise will be in phase. So whatever is in phase that gets into here is being ignored. Whatever gets out of phase is being interpreted as a signal. So here's how it looks like. My oscilloscope. Turn on, bring it here. Okay. And turn on the circuit. All right. So here is pin number 2 signal. And here is the same signal but inverted 180 degrees. And here is the output right here of the amplifier. Clean signal in, clean signal out. All right, let's go a little bit crazy and fun. I just stopped the simulation so I could do some changes. So here, this one here is 0.5 millivolts peak to peak and 0.5 millivolts peak to peak. So this one here, it gives us 1 millivolt peak to peak. Let's introduce a noise, but the noise will be in phase in both of those signals. So let's just get us well 0.2 0.02. let's give us here volt. Okay, peak. Okay, I wonder if that's going to give us, let's give the same thing here, 0.02 volts, and let's turn that thing on. Oh no, that's too much. Let's give it, sorry, 0.002 here. Okay, nice. 0.002. That's going to give us a little bit better. Yeah, look at this. Here is the same signal, but with noise. But look at this. There's a noisy signal, but the output is still clear as a bell. All right. Now let's just give it a little bit more, so it's things that look. Let's add one more zero here. Okay, press play. There we go. See, it looks better here. So here's a noisy line, here's a noisy line, and on the output, things are much, well, they're clear as a bell, clear as a whistle, because these two, that here is out of, these two provide the same signal, but inverted 180 degrees into those inputs here. And they're out of phase, they're being read as a signal. And whatever comes in phase, because that noise is going to be in phase, because if you have two wires and susceptible, they're introduced to some sort of a interference. Of course, the interference is going to be the same and in the same phase in both wires. Whatever is in phase is being ignored. Nice and beautiful, clean signal. Noise is being ignored. So that's the idea of a balanced signal in pro audio systems. Okay. All right. I think we've gone 2 minutes over time. So that's what I wanted to show you. And as I said, tomorrow I will be there. I'll be able to answer any questions. I will be there for whatever the time is. If nobody shows up 15 minutes after, then nobody shows up, then class is over. So I will be there tomorrow to answer questions, and then we're going to have the first test. Yeah, finally we got the first test. Cool. Thank you so much, guys and gals, and I'll see you when I see you. Yeah, it's almost Friday. It is. I taught you something. All right, cool. Bye.